Very good. So for today, we're going to do two exercises all together. The first one, okay, let me share my screen first. Okay, can you see my screen?
Yes.
Perfect. Okay. So the first one will be the DEM scene. And for this exercise, we're going to use the data shared in the class. And first of all, we will have to create a digital elevation model. Okay, so we will use points, contours, rivers. We need to stand the area. Okay, and let's add also another shapefile, the geology. We will use it later. Okay. So what we want to do first is to create a 3D model. Okay. Not just a digital elevation model, but we want to use that in order to create a visually 3D model, to work with it and have further, let's say, observations. Okay. Not just for our visual appeal, but this is a method where when you have good and let's say satellite images or aerial photography of good resolution, this will help you, this methodology, in order to identify areas, for example, with affected by natural hazards, for example, or to see in 3D any changes in the landscape, okay, and the relief. So, first of all, we need to create a digital elevation model. This will can be done through the tools of the analysis menu and by using the geoprocessing tool Topo to raster. And for this, we're going to use the Topo to raster 3D analyst tool and not the spatial analyst tool. Okay, I think we have seen this procedure also. Okay, so in this tool, we will use almost all our let's say shape files. Okay, first of all, we need to add the shape files where we will retrieve the elevation information. So we will use the altitude points and the information can be taken from the altitude, which is a type of point elevation. Okay. We will add another feature. Let's add now the contours. Okay. Which is a type of contour, of course. Then we will add the shapefile, which will, let's say, contain the geoprocessing. Okay, so for this, we will need the boundary. So this study area this polygon will be used as a boundary. And final one. Here we can add more information about to make more realistic our dam. So we are going to use the rivers that we have available. Okay, we don't care about the field because if we use the stream option, you see, it doesn't count as it doesn't retrieve any information, just its spatial information. So here, let's save it at the default place, and let's name it as DM grid. Okay. The output set size usually is the minimum one, which is the best out of the other solutions and options. And now that all our information is retrieved mostly from contours, as a primary type of input data, we will use the contour selection and not the spot selection. For environment, of course, we're going to use the same coordinate system as the rest of our shape files. So let's take it from here. Okay, and at this point, we run. Okay. So
I'm trying to use Topo to raster, but it says tool is not licensed.
okay. Anyone else has this problem? Panagiotis?
Okay for now.
What did you say?
For the
couldn't
moment,
hear.
I'm okay with the extensions.
For you, it's available?
Yes.
Okay. Let me note that down, Vangelis. So, and also the rest of you, please try to do that sometime. And if you face any problem like that, if this tool is not available to you, please tell me so in order to check. So, Vangeli, I note you down because this is an issue of your license. Maybe you haven't finished the whole procedure of your licensing. I mean, there's some stages at the end that you shouldn't skip in order to have the full activation of all, all tool package. Okay, and these tools from the geoprocessing for 3D analyst and spatial analyst tool category, let's say, it is a special say licensing tools. Okay, maybe you just have to log into your online account and just there are some buttons to turn on and turn off. Maybe you will have to go there.
Okay.
Yes, Panagit.
You have to sign in to your ArcGIS Online account through browser and check the licenses tab. From there, you can activate every extension that is available.
Panagiotis, would you like to share your screen, to give you permission to share your screen and show Vangelis in order to do it correctly?
Yes.
Okay.
So I have the same issue with Vangelis, but I'm able to use the extensions because I'm.
Okay. So we are on this part now, where we have. Because, come on. So we have created our DEM, and usually they're better to be visualized using something like that. I mean, as a symbology for graduate colors from green to brown or something like that, because we're talking about elevation. Okay. And we can use the DEM in order to create another raster grid file, the hillshade. Okay, this is also a 3D analyst tool. And from the hillshade, we're going to use the DEM of grid. Okay. Yeah, let's keep it like that. Where here we can use, well, we will create a shaded elevation model. Okay. And imagine that you have somewhere around the sun, you set on your own the sun, which angle the sun will light. Okay. And you on the opposite side, you will create the shade. So the default of ArcGIS Pro is for azimuth on 315 degrees, and the altitude from 0 to 90 of 45. Okay. So this can be changed very easily from you, depending your case study. Okay. So for our exercises, we'll just use the default. It's not a problem. So as you see here, the hillshade looks like that. And usually when you are creating different raster grid, okay, derived from a specific DEM, usually the results are less good on the resolution. Okay, just keep that in mind. This will affect also the resolution of your data. You see here how big are the pixels. Even if our DEM is, let's say, the interpolation for the DEM is good, in order to create the hillshade, things are becoming, let's say, a little bit more rough. Okay, we don't need the hillshade to be viewed now, and we don't need also the DEM at this point. Okay, let's work now and change and work on with our vector data. So we have here the contours, the geology, and the rivers. First of all, let's modify the contours. Okay. Let's use a proper symbol. Okay. Maybe a color. We can use black with 1.5 point of thickness. Okay. Maybe the one will be better. We'll see. Yeah, okay, let's keep it at 1. Okay, and black. Also, now that is selected, we can use some labeling. Okay, and for this, we have to enable labeling. Okay, it goes all over randomly. Excuse me. At this point, we'll have to fix this from here. Okay, so there is an option here at the label placement where it's fixed up for contours. If you use that, okay, it doesn't finish. You see, the GIS understands which is the most important part of the contours to be identified. But still, I would like to change that a little bit. Okay, so in order to do that, we can open the label placement properties. This is a general. Okay, and you see there are some options here how the label placement will be on the contours. Okay, so see whenever we change this, we could change the position. Okay, okay, so I will change the angle. Here. Yes, Panagit.
What's that angle option for?
This is for the label. Let's say if it will be placed the label vertically on the contour or a little bit tilted. Okay, so this is this angle is placed for here, just for that. And usually for the contours, you will need to be a center curve. Well, this is a prefix because we selected the contour placement, okay, which is a new add-on in the ArcGIS Pro. In previous version, it wasn't there, so you had to do all this manually. But if you would like, you can put it like that as in the center, let's say, but straight, the numbers. Okay, this corresponds to the numbers of the label. Or horizontal, well, you understand that this is not good for contours. Okay, for example, like that. No. Okay. And there is also the orientation, but because we have selected this is not available. Okay. And also, if you have some, let's say, okay, in this map, it's quite okay. I mean, the labels, how they're placed around, but there are, more dense contours in other maps. So in this section, the section of conflict resolution, okay, for the position of the labels, there is an option removing duplicate labels. For example, you might have the same number in the same contour, let's say, very close. Okay, this is not nice to see. Okay, so there is an option to remove within a fixed distance or remove all and just keep one contour. Okay, the one corresponding one. Okay. So after fixing this, okay, and fix the contours, let's go to the rivers. Yes, Panagit.
Could you show us how to to cut off that segment of the contours where they overlap the numbers of the altitudes?
Okay. So again, from the river class, before we were here in the first option, the position. Okay. For this, for what I mentioned before, you will go to the third option. Okay, the conflict resolution. You see?
Yes.
Okay. So from here, the first option, the remove duplicate labels, usually is selected by default from at the do not remove. So you can select the remove within a fixed distance, and on your own you can say which kind of distance. Maybe this is the best option because, okay, you can have experiment with yourself and see what it is. It suits you. Okay, let's put some millimeters here, and you have a radius of 150 millimeters of your map. Okay, so around this, let's say radius, no duplicate label can be found. Okay, or if it's a simple map and easy to follow, let's say the contours and the labels, you can select the remove all. Okay, so you won't have any duplicate. For example, you will see only one time the 1000 contour. Okay, one time the 600. For example, if you put that in your map.
I was talking about the altitude numbers that you see on the contours. At some points, the symbol of the contour is overlapping and kind of hiding the number.
Okay.
I know that there's an option to like cut off that segment visually and to make the number stand out a bit more.
Well, there's not an option really. There is, let's say, you can
The modification process that you
on the number you can add a halo around your number. Give me a moment to check. Halo. Okay. So if you add the halo and let's put the white here, outline with 1. No. Also this white. Okay. You see now your numbers are going on top of your contour. So the contour, it doesn't cut it by the number, but your number is visually better.
Yes. Okay. Great. Thank you.
In the ARC map, there was an option in order to cut, let's say, the contour and, have like a rectangle around with your number in that. In ArcGIS Pro, unfortunately, there are some options that are not available now, or if you have to do some tricks, let's say. Okay.
I'm gonna check that a bit more. I believe there's a way because as you can see, like with contour lines, let's say 1200, for example, you can still see a part of the contour that kind of cuts off. So I'm guessing that there is a way to create like a cut-off segment there. But I'm gonna check on that a bit more.
But this could be only visually and not cut, let's say, literally the contour, because this
yes,
will,
visually, of course, yes.
Only visually, perfect. Okay. Okay, now it's fixed like that. let's leave it as it is. It doesn't matter. So we can go also to the rivers and apply a thematic mapping here, having graduated colors for the rivers, and by taking the information from the class, okay, of each river, because we have 1, class 2, 3, 4, and 5th class of rivers here. Okay, of course we don't want this kind of graduate color, but a more blue, more suitable here, and of course not white or pink, what it is. The rivers, and let's keep that. Okay. Let's change the color gradually, and as we change the color, we can change also the width of the line, because as the class of the river is going up, the river has more, let's say, it's more dynamic. Okay, so it's better to symbolize it with thicker line. Okay, and the final one, so I think this color is okay. Let's put 2. Perfect. So we finished also our thematic mapping on the rivers, and let's do the same for the geology. Okay, so for the geology, we will need unique values. I believe you understand why. Okay. Well, in the next class, I think the GIS04, you will learn more things about the visualization of in the symbology of in general features. So I won't show you now, and not me, of course. I think it's Professor Kakan who's going to how to add new styles. So in this case, we're going to use whatever we have on our hands, random colors, and by loading the symbology, here we can see now where the different geology can be found on the map. Okay, but because we're working also with rivers, and the rivers are blue, we don't like bluish color, so we are going to change this and let it be, green. Okay, maybe not. Let's put it like that. Yep, better. And yes, Panagit.
So in cases like this, where you have rivers that you depict them with a blue color, and you have also limestones that I'm guessing cartographically is more correct to depict them as a blue color as well. Is there a secondary option that is usually recommended for different geological layers?
Yes, this is a nice question, Panagiotis. Taking as an example the geology, okay, because we won't use every time geology in our maps, but in this case, Geology has specific, let's say, symbols also and colors. The colors for geology corresponds to time, okay, time of the formation of the specific rock, okay, and the symbol corresponds to the specific rock. So, for example, for the limestone, you can use light blue colors, or you can use white color, but with the symbol of the rectangles. Okay, this is specific for the limestones. So in this case here, we could use.
So we could create like a custom symbol for this case with rectangles.
Yes, let's use that.
Okay, great.
Well, this is a polo. Okay, no, I won't proceed with this. I don't want to ruin
Yes, of course.
the
Yes,
future classes,
okay.
but yeah, and for this, what I did, I had yellow better. For this region here, there are many specific rules and that you have to follow for the symbology of geology. Okay, and it's not something that you will have to remember, let's say, or okay, from the experience you will remember it. Okay, for sure. But there are, let's say, some lists, okay, in the internet from the USGS, the United States Geological Survey, which is a very impactful survey service, where there you can find the matching between the rocks and the type of color or the type of symbol that you will use for this. And because we're talking for thematic mapping, these have to be very accurate, because otherwise someone who is going to read, let's say, your map might not understand it. So you need to be more precise on this symbology thing. But Professor Kalkani, we will analyze later how to create your own symbols, how to use already symbols from other galleries that are not available in the default of ArcGIS Pro, and all these rules. So we just want to change here the colors in order to be more observable for our exercise. Okay, so at this point we have everything in hand, and what we are going to do in order to work on a 3D, let's say, environment is, as you see here, we're working on the map. Okay. In this case now, we would like, here's the map. Okay, if we wanted to open a new map, you can do it from the insert here. But for the 3D, where we have to work on these two options, the new global scene or the new local scene, where our data are very locally. So we are going to use the new local scene. But if you press it from here, okay, let's do it. So it will open a new tab. Okay, the scene tab, and as you see here in the catalog of maps, it created a new scene. Let's say document, but there is an easier way where, let's say, here we have all our data that we're going to use for our 3D analysis. So you can go here. This is for map. Okay. So, and if you right click on that, there is an option convert. So the whole thing here, or whatever you have loaded, it can be converted directly to global scene, local scene, and as a base map. So we're going to for the local scene. It will again create a new tab scene, but all our thematic mapping and our shape files will be here, so we don't lose any of our changes. Okay, because in this case we will have to load them again here, and you understand that the thematic mapping will go off. And at this point, I think I will have to close my video, because you understand things are going a little bit rough. Okay. So now you see, still we have all our data. Okay, still it's not finished. Let's say you see here down right, still drawing. Okay, and now we have this. Let's say on the lower left corner, we have this joystick in order to move around. Before doing that, I would prefer to unclick any of our data here. Okay. Or our layers. And we don't want this. Let's keep one. Okay. That option here. Okay, let's move on. So you see here in the content of our layers, we have some options here for the 3D layers. Okay, if we had one, those that we have created before, there are 2D layers. So the GIS import them on the corresponding here place. Okay. Also, it added some topographic map here and the world hillside that we already had in our map, and the GIS added one extra layer, let's say, group, which is called elevation surfaces. And from this group, it will, let's say, retrieve the information of the elevation in order to create the 3D content. So from here, usually it has like, the base maps. So here we have the world elevation 3D terrain. Okay, and if you unclick it, you don't have anything. In the case of scene, okay, and from here we want to retrieve the elevation information by doing right click on the ground group, let's say, and you see here we have the elevation source layer. From here you can only add raster grid files. So here we can select our DEM of grid that we created before. And don't need that now. And as you see, what now we have is the elevation only from our DEM that we created before. Okay, so we don't need now to take the elevation, the general elevation from the whole Earth. And it is combined with the topographic map or the base map of the 2D. Okay, so let's go now a little bit and do some zoom here. And before starting working with our data, let's have a look around on what we have now on this 3D model. Let's say the most simple one. If you click this button here, you can have full access to the whole joystick, let's say, because here we can move around as a 3D. And this needs some exercise in order to get accustomed with that. By clicking, you see it becomes blue. By clicking the ball in the center, you can change your angle of view, okay, the 3D. Okay, I change that. And in order to move around, you can click the inner circle, let's say, and do that by your joystick, right and left, right and left. Using the scroll of your mouse, you can always go in and out. So if you change your angle and go with your mouse in, you come closer to your 3D model. And by using the pen and drag, and you can move around on the specific angle that you have selected for, okay, and the view. And if you want to do more accurate and precise movement around, you can use the outer circle, but watch out when I'm clicking. You see there is near my mouse, there is an arrow. The arrow shows the direction of my movement. When I have my mouse close to the outer circle, the speed is slow. When I move it outer, you see further away, the the arrow becomes bigger, so this indicates the speed, okay, of your movement. Perfect. So what I've done here is I use the base map, let's say the satellite image of ESRI of Google, it's the same. In order to, let's say, paint my digital elevation model. Okay, so this is exactly on top of our digital elevation model. So here, by clicking on that and going to the properties of the world topographic map in this case, okay, and go to the elevation, there are some options. Well, this says that it is on the ground, so it is exactly coming in contact with our DEM. So if you would like to not put everything in one, you can check here, you can change here the offset vertically in meters, let's say, okay, and change this elevation. So give it a moment. Okay, like that here. Okay, let's change also the hillside. Okay, you see now what's going on? If you see here, maybe okay, I will give some more distance in order to be easier to observe. Let's put 50. Let's put 50 here too. Okay, now it's done. So if you see here, you see the distance, the difference between the world topographic map and hillside, which is the green. Okay, that's why I'm going to that side, let's say, on the right side, and below it is our elevation surface, our DM. You see? No, if I do that, okay. If I do that, there is no information about the elevation, so it flies away. But in this case, now you can see here. You see, there is an empty space behind that. And why this is, let's say, good to do, this might help you have an, let's say, an understanding about when you have multiple layers in order to interpret with your topography. Okay. Okay, let's move on. This was in order to retrieve some information from the topographic map. If we don't want this topographic map, and let's change the base map and put some satellite images. Okay. That's much better. Okay. And let's see again the elevation. Okay, we have to do it again. So you see now it's more realistic. And because we have already created our own elevation surface and not using the one of their GIS, you see our study area is very, let's say, focused, and we work only on that. Okay, so imagine that you, instead of using the base maps of the GIS, you have your own aerial photography from your drone, from the Greek geographical survey, army, and etc. And you are using that in order to have a better view of your data. Okay, to do more realistic analysis. In case you use your own drone, for example, and work for that, you can do different analysis and see, for example, okay, in this case here, we have a canyon. From the past photography, from aerial photography that I bought from GIS, here I have, let's say, a general view of the area of, I don't know, at a specific age, a specific time. But today, I know that this place here had a very strong earthquake, and there were some, let's say, this is a hazardous area. So I go there and using my drone, I take my own aerial photography, and I can interpret here. I can add also my aerial photography from my drone and correlate it on the same time in order to find any changes in the landscape. So in this, let's say, places here, it could be some accumulation of debris. Okay, so this would be easier to view in this kind of analysis here. And if you want it now to do it more, let's say, realistic, you can add your shape files that you used thematic mapping before. So you see here, you add also your own information here. Okay, sometimes it's stuck, you see. So it goes all along. And if you want to add also some information further, you can add the contours. And you see here on the the contours or the rivers on this kind of data, there are two kind of options that you can use for the elevation. The one is on the ground, okay, that we saw before, but there is also at an absolute height, which says here these features known their exact height, such as the airplanes, for example. So if you have extract any information from your drone or any other, I don't know, aerial input where they had a specific height, you can do it here. But also by using that, you see, you can do an exaggeration. So in case for, let's say, doing more here, excuse me, better to reverse, to emphasize some of these features of yours, you can do that here. Let's see the result. Give it some time. Okay, well, now it's below because let's say the ground now was the hillside, the world imagery. Okay, so now that we put it on 4 meters, it came below in this case. Okay, let's check again. Let's put 55 in this case. You're still there. Okay. You need to play a little bit in order to have this. Went back. Yep. went back now. Okay, so also this might help you in order to have a better understanding of the area concerning using the topography and the geology for this, let's say, in this case. So if we had also the geology here, of course, let's say we will lose the topographic, not the topographic, the imagery of the satellite, but still we keep the topography, as you see here. But in this case, and if you also, let's say, go to the geology here, and why not have some transparency? Okay, here we are. And okay, let's do something else. And instead, the word imagery, let's use our hillside. Okay, it's more pixel, but okay, we can do our work. So in this case now, that before you identify the areas where you had, let's say, for example, the debris cones and the more, let's say, like here that we talked before, in this case. Now that we have added also the geology, you can evaluate your observations. For example, in this case here, we have a contact of limestones and some dolomites. And so because we have here this contact, and we have also the rivers, this is an area, for example, that can produce more debris after an earthquake. This is, for example, okay. And you see also here, we had an old different debris cones that was mapped in our past, let's say, mapping period. And you can do, you can change also here your maps and create more accurate maps using this 3D scenery. And just let's say to have an idea about this, if you have good let's say graphic cards in your PCs or laptops, this works even better than you see now in my case. And you can do many different things. This can be also here can be recorded or export like other projects here, or you can upload it as a new web scene. So you can share also your work. And yeah, if you don't try use that,